right after what's it, an Indian tech support. Hello, this is Indian tech support. I would like to take your call, but I cannot help you. I'm going to have to put you on hold. Okay, thank you. Goodbye. I'm actually here today to help you guys understand nuclear energy and help you make it simpler and make it easier for you to understand so you don't have to be so afraid of it and it doesn't hurt to think about it. So the first thing I'm going to start with in nuclear chemistry is I'm going to start with the process of fission. And I'm going to resort to the very reliable source of a webcomic, the Sheldon webcomic. So nuclear fission explained. The first step in nuclear fission is first you fire a neutron at the uranium-235. So this is our little neutron here. This is our uranium-235. Our second and third steps of nuclear fission involve uranium first absorbs the neutron, but it's unstable. You can see they're little freaks out. They're unstable right now. So fission occurs. They fall apart, and the isotope slips into lighter elements and free neutrons. Oh, and energy is released. So our energy here is actually the process of nuclear chemistry that we're going to be looking at in most detail today. So the energy that's released is actually released in the form of gamma radiation. I've got an equation up here. We start out with our uranium-235, and then we fire the neutron at it. So after we fire the neutron, it falls into the cat and the dog, or the now stable, smaller elements. And it also releases the free neutrons. And then the spit from the little lizard is our gamma radiation. So this gamma radiation, this is how it's represented here. Gamma radiation is just pretty much a fancy mumbo-jumbo way of saying we add energy to the system. And that's what we're going to be talking about a lot. So we have our gamma radiation coming through here. And in the case of nuclear power plants, it's mostly reacting with water molecules. I didn't feel like doing a full drawing of the water molecules, so you'll have to do a simple representation. So we have many different types of reactors. All of them that I'm going to go over today utilize water. I'm actually going to ignore this one though, because I didn't do as much research as the other three. So the different types of reactors, I'm going to start with just a basic representation of the reactors. So in our reactors, we have the uranium-235 here, and then we have our control rods, and then we have the water cycling through here in a closed system. This is very important, especially for safety reasons. We have the water that flows through and goes past the reactor core. And in the reactor core, it's really hot. Like I said, the gamma radiation is coming out, and it's exciting the water particles and heating them up. So then our heated up water particles go through a system that goes through a steam generator. And this is where it heats up more water here. Again, it's in another closed system. It heats it up and it creates steam. This steam then goes, and it, like anything hot, it rises, and then it goes through past the turbine. And the reason it wants to go past this turbine is because there's cold air down here. So it's starting to condense the water. So it'll get the turbine spinning. So, and then it goes back, and it just keeps moving through the system to be continually used. And then this bit right here is the coolant line. In a diagonal power plant, I'm pretty sure they use seawater as a coolant, but then you'll notice it's not going to be radioactive because it never comes in contact with radiation like this one system here. In fact, with the diagonal power plant, this water never leaves this system here. So then it goes, after we get our electricity from the turbine will be spinning, we'll get it through the generator, and then it gives us electricity. So that's kind of a basic overview of power plants in general. So now I'm going to focus on pressurized water reactors right now. It's called pressurized because, let's see, well, it's pressurized. It has a pressurizer down here. And it's the same sort of process that I just described to you. We have the reactor core, and then we have a closed system of water going through here to heat it up. And then it gets, it heats up the water and makes some steam in the turbine. And then the water from the steam is condensed in the condenser here, and it's sent right back into the system. Boiling water reactors are pretty much the same sort of thing. Just got the water flowing through here, going to the core, and then got the other water comes and it's going to the turbines. Again, the same sort of basic idea as we just went over with the first one. So then breeder reactors, this is one that I'm actually not too sure about, but I know that it's got the same sort of structure on the inside of the core reactor where it's got the control rod. I'll be going into this in a little more detail in a minute here. And it's got the body of the cycle, so again, a closed system, and then the steam that goes through gets condensed and spins the turbines, and then our cooling system right here. So, I'm sure all of you are thinking, gosh, radiation is really dangerous. And the truth is, it is. It's really dangerous. But there are ways of controlling it. This is one of the things that people that work on nuclear power plants, or that originally built up, would come up with. So we have control rods, aptly named, I think. They absorb the neutrons that, in our nuclear reaction, we have the fission, and we have the electrons, the element splits up and releases more neutrons. So the neutrons that come out will generally start off a chain reaction. That's the sort of thing that happens in a nuclear bomb. So to stop the chain reaction from happening, we have an absorber of the neutrons, and that's our control rod. And I went over it in detail in my paper, what sorts of things you could have in it. I believe boron was one thing, any others? That's okay. I think cadmium was one too. And then to make sure that the reactor doesn't get too hot, we also have the coolant that goes through it to keep it cool, and then also the water cycling fluid to help keep it cool because it's taking away the energy from the reactor core. So, yes, and it also absorbs neutrons. So now I'm going to pass the time over to my sister, and she's going to tell us why nuclear power is better and generally safer than probably thought.
So, as you all know, there's lots of different types of methods of producing electricity. And so today I'm going to go over some different ways, compare and contrast different ways that electricity is produced.
So many benefits of nuclear energy.
Yeah. I know. Anyway, so to start with, I'm going to be comparing it to coal power. Coal power, 100,000 kilograms of oil is equal to 1 kilogram of uranium in the amount of power that they produce. I know that they sell like little things where they've got a little uranium pellet that's maybe about that big, and it produces as much energy as hundreds of kilograms of oil and coal and other things. So because less is used, less is mined. And with coal, you have to dig up, and fossil fuels, you have to mine lots of resources to burn. And because we use less uranium, we don't have to mine nearly as much. And because we don't have to mine as much, we don't have as much of environmental impact. So we aren't like tearing up huge amounts of land to get just a little bit of energy. We get tons of energy from just a small area of land. Now, solar powers, they may seem really cool because, like the sun, is not going to go away tomorrow, is it? So, but there's some problems with solar power cells. The components in solar power cells, they degrade rapidly, and because of that, they don't last as long and don't produce as much power as we might like. And also, the chemicals inside them are really toxic, and they have to be disposed of in a special way. So it's really expensive to get them and to get rid of them too. And nuclear power, you can generate, like I said, you can generate a lot of power with nuclear energy, and it lasts a long time. A little bit of uranium can last, I don't remember how long. A little bit of uranium lasts a really long time. But also the problem with solar power, great up in space, but then down below this thick atmosphere that we've got, it really cuts down a lot of the power that we can get from solar panels. That's part of the problem with them. Like I said, the materials are expensive, so it's really just not very practical down here on Earth with all of the expenses and the atmosphere. Now, windmills, they are very inefficient. We have to put them in specific areas where they can get lots of wind blowing through, and you have to have like hundreds to produce energy. And I've seen ones that are like trying to make them more efficient by having the blades rotate and the heads rotate so it can get wind from any angle. But it takes up so much land, and you sort of like build one in the middle of the desert and not really take over any environmental issues or anything.
And we don't have to worry about putting a nuclear power plant in the middle of like a rainforest where it could harm animals just because they can go anywhere. They're not reliant on the environment.
Yeah. The nuclear power, different ways it can be used. It can power our houses and electronics. It can give us practically unlimited amounts of electricity if we had enough nuclear reactor power plants to make energy, to provide everybody with energy. We could all have as much electricity as we want. We'd have lower electricity bills. Granted, your neighbor could probably get that annoying ringing doorbell they always watch it, but that's not a big problem. And it can also power ships, aircraft, and submarines. I've got a little picture here. You guys can look at it later. You guys can have a look at it later. But there's lots of submarines and other water and aircraft that are powered by nuclear energy. Also, one time when there was like a power outage in a large area, they were able to get it powered by hooking the nuclear powered ship up to it.
Yeah, they had a submarine. They had it right nearby a city that just lost a bunch of power, a complete power outage. And they said, hey, this guy runs on nuclear energy. They've got a lot of spare energy. Let's hook it up to the city, and it worked.
Yeah, and people didn't have to worry about like being without power for days. And also, electric cars are really nice because they use electricity instead of gasoline. And if we had nuclear power plants, we could make enough energy to keep powering the batteries and the cars, so we wouldn't have to worry about them being expensive anymore. And also spacecraft. Unfortunately, all of the nuclear-run space programs have been shut off because people just don't understand how safe it is and how cool it is.
Yeah, it's really efficient.
Yeah, it's really efficient. I didn't get any pictures up on here, but there's a couple pictures here. My dad's showing on Orion. It would have been able to go like much farther than our rocket fuel propelled ones. And then also there's Nerva, which is a rocket engine, and it was going to be nuclear powered, so it would have been a lot, would have been able to propel it farther without using as much weight, which would have meant that we could have had smaller spacecraft, and also we could have had more stuff on the spacecraft, take more stuff in space, not have to worry so much about fuel. So that's all we have to do.
Couple questions, then we'll go to our next presentation. Wendy?
I have a question. You guys were talking about the difference between nuclear and solar power, and you were saying that nuclear, I believe, was better than solar power.
Yeah, basically.
Okay, if that's the case, then why are like the big giant electrical companies, PG&E, going more towards solar than nuclear power? Because right now they're building solar power plants.
Well, a lot of people don't understand just how safe nuclear power is, and so they hear like nuclear and think explosions, catastrophe, it's going to be horrible, and so they think, yeah, they think Godzilla and stuff like that, and so they don't realize just how safe it is, and they think that solar will be better because it's not as dangerous.
And also, there's a lot of political leanings towards solar power because it does seem like such a nice idea, and so there's a lot of politicians that are just like, let's use solar power.
Well, how safe really it is, like in the case of an earthquake, in case where the closed system is open up in some kind of manner.
Oh, like, that couldn't happen.
It's got a steel containment structure and cement around it.
Yeah, I know in the recent disaster in Japan that the reactors broke apart and were destroyed. Those were really old reactors. One that my dad worked at, Diablo Canyon, it could be on a fault line and it would be perfectly fine. It wouldn't break apart or anything. It's really stable. The wall is very low. It's like a mile or something.
Really thick. They
make them thick enough to be safe and then a little bit more. Yeah.
Okay, I'm going to stop questions. I know you guys have tons of more questions. You can talk to them after because we have one more presentation And I want to get to that. So let's thank these two for the wonderful. Become more informed on our different energy sources. So you guys can make choices about how, the politicians are, all your politicians are behaving. Okay. So I will ask one thing before we start this next presentation. We are like right at the line. I'm gonna lock the door. If you have a class right now to go to, please do not leave in the middle. Please leave right now. Okay? I'm sorry that this went right to the end. If you want to support your fellow colleague, then colleagues out there supporting you, you can stay for an extra few minutes.